Hello everyone, I'm Autonomy, and today I'll summarize our work communicating robot conventions through shared autonomy. Imagine you have a wheelchair-mounted arm that you use every day around the house. While this may work in most scenarios, teleoperating this robot poses a significant challenge when you need to reach for things on a cluttered desk. Our work explores how to leverage conventions for shared autonomy in such scenarios. How do current shared autonomy methods work? These methods generally are given a set of tasks, and whenever you use the joystick to command an input, the robot tries to infer which task you want. When the objects are far apart, the inputs you give are distinct and the inference works really well. However, what about the cases where the objects are close together? Now the inputs you give are not that distinct and it makes it hard for the robot to predict. The best way to get around this problem is to recognize that the robot is actually relying on a mapping between the joystick inputs and the tasks. We can actually think of these mappings as a type of convention. So now in this scenario, if the human were to exaggerate and press left on the joystick instead of going straight towards the soup can, it would make it easier for the robot to figure out what the human wants. While this seems easy in our simple example, it may not always be that obvious in the real world. So what can robots do to convey their conventions? Through this work, what we found is that robots can reveal their conventions by showing communicative inputs. What I mean by that is when a robot is given a discrete set of tasks, theta, and it has a specific convention pi in mind, the robot takes in the human's inputs at each time step and estimates which task that the robot is working towards. Once it figures out the task, instead of just helping the human with their task, the robot can leverage constrained optimization to find an action that reveals the convention that the robot has in mind. There are two main parts to this optimization. First, the robot needs to figure out what action it needs to take to communicate its convention. And second, it needs to ensure that this communicative action does not hinder the robot's ability to actually complete the task. To understand the importance of each component, consider the scenario shown here. The robot is equidistant from a notepad and a soup can, and the human wants to reach for the soup can. Now, if the robot were to choose the most communicative action, it will lead to the robot moving up. This way, it is completely avoiding the notepad and makes it extremely clear that the human wants the soup can. However, if you were to move in this direction, the robot is not going to reach for the soup can. Therefore, our constraint ensures that the robot is taking actions that both complete the task and communicate the convention. We conducted a user study to understand how our method works with real people. First, we had humans learn the robot's convention through repeated interactions. For instance, if the human was reaching for the notepad, the robot would recognize this and start exaggerating in that direction, thereby revealing its convention. Next, we wanted to see if humans can actually transfer these conventions to new scenarios. And finally, we also wanted to test the limits of our system. So we gave the robot an unintuitive convention, and we wanted to see if the robot can successfully communicate this unusual convention. Across all of these tasks, we compared what happens if the robot did nothing to reveal its conventions, if the participants were given the conventions in writing, and in our method where the conventions was shown through actions. In comparing across these methods, we found that people adopted the robot's convention best when the robot was actively guiding them. However, they did not transfer this learning to new scenarios. So they would only follow conventions when the robot showed them what the convention was. And finally, when the robot has complex or unintuitive conventions, people were able to pick up the robot's convention when they were able to visually see what the convention was. Thank you, and I'm happy to answer any questions.